Okay, so here's number 8. So what we're doing is we're doing another scatter plot. So this is a scatter plot. And this is kind of an interesting one. What they're doing is they're doing a relationship between volume and height. This is height there. Height for cherry trees and the felled black cherry trees. And then down here, they're doing the connection between volume and diameter. So what does that mean? Let me help you understand what all these little dots mean. Like this dot right here. This means that each one of these dots represents a cherry tree that they cut down, a felled black cherry tree. So in other words, everyone has an X and a Y value. Like this one dot is what, over, I don't know, I'm guessing it looks like about 80, right? This looks like about 80. And it's up, I don't know, I can't really tell. What's this, 20, 30, 40, 50, maybe 60. You don't have to know these exact. I'm just eyeballing it. Looks like it's over 80, up 60, right? So what does that mean? That means that the tree was 80 feet tall. This is height in feet. So the tree was 80 feet height. That was how tall the black cherry tree was, 80 feet high. And the volume in cubic feet, meaning that's how much wood. That's the volume of wood when they cut it all up to make paper and timber that we use to build buildings and have paper and stuff. They got 80 cubic feet of wood out of it. That's the volume in, or sorry, 60. They got 60 cubic feet. So that one dot, which connects an X and a Y value, is one tree. An 80-foot tall tree gave them 60 cubic feet of lumber. And then there's another dot like this one. This was an 85-foot tall tree, but it actually gave them less lumber. Isn't that weird? It's a taller tree. Looks like it's about 85 feet tall, maybe 84, I don't know. And it looks like it's around, I don't know, 32. So it's a taller tree, but it actually gave them less lumber because it must be a thin tree. It must be tall but thin, so they didn't get as much lumber out of it, etc. Every one of these dots is how tall the tree was. Maybe that one's like 68 and they only got 20 cubic feet of lumber out of it, okay? And then the graph down below is a connection between diameter. So like this dot right here, this is a tree that is 16 inches in diameter. So they measured how round the tree, how far across the tree is. That's diameter. And it says right here, the diameter was measured 4.5 feet above the ground. So they went 4.5 feet off the ground and they measured the diameter of the tree, like how far across, the thickness, in other words, diameter, that's the thickness of the tree at 4.5 feet high. At 4.5 feet up, they measured the thickness, the diameter, how far across, and then it looks like it was about 39 was the volume, 39 cubic feet of lumber they got out of that tree. Here's another tree that looks like it's, I don't know, maybe 13 across, and they got, I don't know, what's that, 20, etc. So every one of those dots is a black cherry tree, and they measured the diameter versus the volume. Here they're measuring height versus volume, every one of these dots. Okay, so what? Well, who would care about this is a lumber company that goes out to cut down the trees and supply us with the timber we need to do the things, build houses and do things. So this is a scientific way that lumber companies could use data to help them predict which kinds of trees they should cut down to produce the most lumber possible. They want the most volume they can get. So the question is, which set of dots is closer? Well, definitely these dots. These are tighter dots, aren't they? Do you see that? You could fit a line through here and it would be a line that fits pretty tight. Whereas up here, yeah, you could fit a line, but it's a pretty loose line, isn't it? You with me? Whereas down here, this is a tight line. So what I'm saying is these dots, whoops, these dots, these dots fit closely. So it's a strong connection. It's a strong connection between diameter and volume. There's a strong relation. You know, measuring the diameter, how far across a tree is up at 4.5 feet, is a strong prediction of how much wood you're going to get out of it, right? Those dots are tight, right? They fit close, meaning it's really predictable. Whereas up here, you know, these dots fit loosely, pretty loosely, whereas these fit closely. It's a weak connection between what? Between height and volume. In other words, height is not always the best prediction of how much wood you're going to get when you cut down a tree. We can see it, right? Looking on the diagram, like this dot right here, he's 80 feet tall and produced 60. This one's 85. This dot right here is taller, 85, but he only produced 32. He produced less volume. So it's not a very good prediction. The dots are pretty widespread. So that's what this question is about. And why lumber companies would care is that would tell them they should be measuring diameter to predict volume, not looking at the height. The height is not a good prediction. So then coming down here, let's answer the questions. Between height and volume, there's a weak connection, right? Whoops, I did the wrong color, didn't I? That's the blue one. Weak connection between height and volume, right? That's up here. That's a weak connection. Whereas between diameter and volume, that's a strong positive connection. And therefore, you basically read this question, it says, what should you use? Which of these variables would be preferable to predict the volume? Diameter for sure. So use diameter, not height, to predict volume. So here's how they would use this. This example shows us a very practical way they could use scatter plots as a scientific tool to help them figure out which kind of trees they should cut down and which ones they should just leave alone to maximize their timber in their work. So there we go.